This is section 8.10, and we are going to continue with the disk method, but we are going to learn how to create a solid by revolving around other axes besides the X and Y axis. Essentially, we're going to do translations of rotations. All right, so the really important thing to remember is that you should always think about how you describe, like how do you describe that radius? Don't know why, but my highlighter, oh, there it goes. You want to be able to describe the radius. Okay, so I'm going to do this in a very general sense. Remember that your volume formula is pi. See if I can highlight this. So it's pi times the radius squared times du. So I wrote du here because I don't want to describe it as dy or dx. Just depends on the orientation, right? Okay, so you have to remember that basic setup for the disk method. All right, so I am going to rotate a function f about the line y equals k. And my function f will be greater than k. Now, you have to remember what y equals k would look like. That would be a horizontal line. And my function is going to be above that line, thus greater than. So I'm going to draw the line y equals k. Maybe I could try a little straighter. I'm having trouble with straight lines. Okay, there we go. So that's the line y equals k. I am going to rotate about that line. All right, and then we draw the function f. Now f is greater than k, so that means f is somewhere up above. So this is my f of x. All right, so if I'm rotating about that line, it's important that I mark the radius. And the radius will be perpendicular to the axis of rotation. So that means I have a vertical line for my radius. I'll just call that r. All right. So rotating that about. So what do I have to do is describe that radius. And so my radius would be equal to y top, which is f of x. All right, so y on the top is f of x. Y on the bottom is a constant. So this point here on the bottom is always k, so minus k. And that is my radius. Again, I would just apply that to my volume formula. Right now, I just want you to, we just want to practice how we would define the radius. All right, this time, so in the next example, so I'm going to rotate f about the line y equals k again, but this time f of x will be less than k. So that means my axis of rotation will be above f. All right, so here we go. Here is the line y equals k. F will be less than k, so somewhere down here is my f of x. I'm going to rotate about that line. All right, so I need to describe my radius. So I draw a perpendicular to that axis, and that would be my radius. All right, so let's just describe r. So r is equal to the top value, which is a constant. So the top value is always k. So start with k. Y on the top is just k. And minus, so to get that length, we're going to subtract that bottom value. So subtract, and that bottom value is represented by the function f of x. And so that is my radius. All right, so just practicing getting that radius. Whoops, looks like my borders moved. So give me a second here. Glitches. Here we go. Okay, let me scroll up. All right, we'll just do the bottom half. All right, so next we're going to rotate our function f about the line x equals h, and f will be greater than k. So x equals h is a vertical line. All right, so what's this going to look like? So I have a vertical line, x equals h. Oops, let me fix something. X equals h. And my function f is greater than that. Oops, this should be an h right here. All right. And f will be greater than that. So that would mean f would be to the right. So I don't know what f looks like, but assuming it's a function. All right. And so f would be to the right. And so my radius has to, so I'm going to rotate about the line x equals h. My radius has to be perpendicular to that axis, so it's going to be a horizontal line. Now all we have to do is to describe that radius. So what's r going to be equal to? R is equal to, so since it's a horizontal line, I have to go the x value on the right minus the x value on the left. Now on the left, the x value is h. On the right, it's defined by some function with respect to y. So we'll call that f of y. So it's x on the right, which is f of y, minus x on the left, which is h. And so that is your radius. One more. All right. Rotate f about x equals h, where f is less than h. Okay. All right. So this time rotating, so we're going to have a vertical axis. So that's x equals h. And so this time I'll put my function f. So this function f has to be with respect to y to do this. Okay. And I'm going to rotate about this vertical axis, which means I need to draw a radius perpendicular to that axis. And so this is my r. All right. So again, always, since it's horizontal, I'm going to start with x on the right, and x on the right is just the value of h, and x on the left is some function value dependent on y. And so the radius is equal to h minus f of y. If you can do this, you can pretty much do any volume of rotation.